So in those last videos, we talked about two-sided limits, which was the idea of approaching an x value from the left and the right simultaneously, and that for that two-sided limit to exist, they had to match up with each other. What we're going to do here is break it apart to just approaching from the left or just approaching from the right. So our notation, how it changes, is basically one tiny little symbol. In this case, it's like a has almost an exponent, so it has a symbol of a negative there. And what that's going to relate to is approaching that value of a from the left-hand side. So how I would read this is the limit of f of x as x approaches a from the left is equal to L. Then our other format is, instead of the minus, to use a plus sign. And if we're using a plus on a, then that would mean we're looking at from the right-hand side. So the limit of f of x as x approaches a from the right is equal to L. So left-sided limit, right-sided limit. So the left-sided is going to look at x values that are just a little bit less than a, and then our right-sided limit is going to look at values of x that are just a little bit more than a. So if we think about a number line, and let's go ahead and put a there, and then let's make sure our number line should always be increasing from left to right. So let's say I had like some negative numbers, -2, -1, 0, 1, 2, something like that. If I'm evaluating the left-sided limit, I'm grabbing values that are just below a, and I would be looking at getting closer and closer to a from just to the left. So this would be from the left-hand side as x approaches a, and then I would use that little minus symbol to show that it's from the left. And the right-sided limit would be values that are just a little bit more, and we would be getting closer and closer to a from that right-hand side. So this would be from the right. So x approaches a from the right. So what can be difficult, and maybe it'll make it worse by pointing this out, but like the arrows that I drew, so from the left, it's actually an arrow pointing to the right-hand side, but we're approaching from the left. So kind of think of starting far left and then getting closer and closer to a. And then from the right, even though that arrow I drew is technically going left side, think of it as starting out way off to the right and getting closer and closer from that side. Okay, so with that, let's take a look at some examples. So we have a piecewise function here, and what we're going to do is evaluate our one-sided limits, excuse me, as well as our two-sided limit. So looking at all three of these notations, the focus is x approaching 2. So something I'm going to do is, first off, let me put some units on this graph. There's 2. Each of these blocks is going to represent a unit of 2. That's what we're doing here. Okay, so x equals 2 is happening right here, where we're jumping our piecewise functions, kind of moving from one trend to another. So if I want to evaluate the limit as x approaches 2 from the left of our function, so that's the idea of starting on the left-hand side and getting closer and closer to x equals 2, which, if I'm walking along the function, means I'm following this part of the linear function, getting closer and closer to that open circle that's undefined. But as x approaches 2 from the left, we're getting closer and closer to that location, and that y value that we're getting closer and closer to that's at that open circle would be a value of 3. So this would be approaching 2 from the left-hand side, and our outputs would be getting closer and closer to 3. Doesn't matter what's happening to the right-hand side for this limit. So my answer for that left-sided limit would be a value of 3. If I want to approach 2 from the right-hand side, so with that, I would be starting over here and getting closer and closer to 2 for these values just above 2. So along my function, what that would look like, it's kind of following, I think this has a little bit of curvature to it, but dropping down to that defined point at 2, which has an output of 0. So that part of the graph, we're decreasing down and x is approaching 2 from the right-hand side only. And with that, the y values on that part of the graph would be getting closer and closer to a y value of 0. So our limit for our right-sided limit would be a value of 0. If we've evaluated the left-sided and right-sided limits, then when we go to evaluate the two-sided limit, if they match up to the same location, then that is your two-sided limit. If they're different, then that means the two-sided limit, so as x just approaches 2 without any other little symbol on it, that limit does not exist. So if we've evaluated those two and they're different, then it does not exist. So that's a property that we have, and that's what's defined down here, is that the limit as x approaches a from f of x equals L if and only if that left-sided limit is L and that right-sided limit is also L. So if they're the same, then that's your two-sided limit. If they're different, then that limit does not exist. Let's take a look at another scenario here. We're going to go back to the graph that we looked at in the, I believe, our examples video for two-sided limits. And let's go back to that scenario that was happening at x equals 4. So when we looked at this before, we only looked at the two-sided limit and we said it does not exist because they approach two different values. But what if we now broke it apart into right-sided, left-sided? So our first case here, we're looking as x approaches 4 from the right-hand side. So as we're getting closer and closer to 4 from the right, our function is following that horizontal line. And our y value that we're getting closer and closer to, well, really our y value is just staying the same, is a value of 1. So our right-sided limit is equal to 1. And then for our left-sided limit, so x approaches 4 from the left-hand side, so you'd be getting closer and closer for these values, just less than 4. And our function is going up and up to that undefined point, which seems to be, just going to estimate here, it looks like it's a little bit more than 3.5, so look, I'm going to call it a 3.8. We're just guessing there. And with that, that would be our limit from the left-hand side. And then because those two are different, even though we can get values for the one-sided limits, the two-sided limit does not exist because they're approaching two different values. So that's a little breakdown of our one-sided limits and comparing it to our two-sided limits.